Okay, here is problem 14.4.28 T from the chapter 14 homework. And this is a pretty complex problem. So it's just got a lot of parts. So I'm going to try to walk through each of the parts for you. So I'll just read the setup. The following table shows the number of wins 8 teams had during a football season. Also shown are the average points each team scored per game during the season. Construct a 90% confidence interval to estimate the average number of wins for teams that scored an average of 23 points a game. Okay, so first thing we have to do, we'll just open up our data table here. And I'm going to open it in Excel. And I actually have the book up. You can see behind the problem I have the book, and I've copied and pasted, or copied the formula, and I'm just going to paste it right here into my Excel file to make it easy for us as we're going through this, or make it easier, I should say. So the formula that I copied out of the textbook is right here. This is for a confidence interval for an average value of y. Okay, and then as I always do, I'm going to start with what I know. Right, that's always our process. Start with what you know and work from there. So we know that n, or the number of ordered pairs in this, is 8. That tells us right here 8 teams, or you can count them right here. So n is 8. We also know that we have a confidence level of 0.9. And if I want, I can extend that to an alpha of 1 minus the confidence level, 4.1. And I also know that my x value for this process is going to be 23 points a game. So x is 23. All right, so now what I'll do in essence is I'll just look at this formula and I'll start to figure out each of the constituent parts of the formula so that I can use the formula. So the first thing we have to find is the y hat. Remember, y hat means the expected value of y for a given value of x. And since this is a linear regression type of model, the easiest way to get the information we need is to use Excel's statistical functions. So I'm going to go to data. I'm going to make this full screen for a second. So when I go to data, I have my data analysis tool installed. And then I'm going to scroll down and do a regression analysis. When I hit OK, it's going to ask for a y range. So this is my x range, and this is my y range. So the y range is going to be B2 through B9. My x range will be A2 through A9. And then it's going to ask us for an output range. You can have it show up on a new worksheet. I usually like to just put it right on the same worksheet. So you click in there, and then you just tell Excel where you want it to put this regression data. Now, if you don't see data analysis on your toolbar in Excel like I just showed, it's because you haven't set it up yet, which is something we actually did earlier in the class. But if you've forgotten how to do that, you can go to, what was that, File, and then go to Options. And under Options, you can go to Add-ins. And under Add-ins, you go to Manage Excel Add-ins and hit Go. And then you just click on the Analysis Tool Pack, and that will enable it on your toolbar. So I'm sure most of you already have that set up from earlier in the semester, but just in case you switch computers, or if you're using a lab computer, of course, those reset each night. Anyway, so here I've got a bunch of information. And for finding my y hat, this is my important information right here. Let me just highlight it. This is my linear regression information. So the intercept is the y-intercept. If you remember back in high school, you learned that y equals, or maybe in middle school, you learned y equals mx plus b is the formula for a straight line. So the intercept is b in that formula. And then the x variable is the slope. I don't know why Excel calls it an x variable, but it does. And that's the m in that formula. So if we're going to solve y hat, an expected value of y given a value of x, I'm going to use this formula. This equals m, which is, again, the slope times x. There's our given value of x, plus b, which is our intercept. So given this data, we would expect a y value of 9.019 given an x value of 23. Okay, so that gives us our y hat. The next thing we need is our critical t-score. Remember, we're using a t-score when we're doing regression because well, we just don't have enough data really to use a normal curve. So always use the t-score. So our critical t equals t.inv.2t. And remember, when we're using 2t, that we don't have to divide the alpha by 2. Even though it's the t of alpha divided by 2, when we tell Excel 2t, it's already doing that for us. So I'm just going to use my alpha, and then our degrees of freedom. And our degrees of freedom, when we have two ordered pairs of variables, is n minus 2. There's our critical t. And now as we look through the rest of this, like I said, all we need to do is kind of look through this and make sure we have the variables. We have n, we have x minus x bar. So x bar, if you remember, is just the mean of our sample. So I'm going to say this equals average. It's going to be the average of all of our x values. And then here's the sum of x squared. Okay. So the easiest way to do this that I know is just to create another column for x squared. And in that column, we take our value of x, we square it, and then we complete that all the way down. So our sum of x squared will just equal the sum of all of those x squared values we just calculated. Told you there was a lot of moving parts in this problem. And then here we have the sum of x. So again, I'm going to do sum of x. This will equal the sum of all of our x values. And that gives us all the data we need to now do this formula. I know it's a lot, right? All right. So if you think about it, this portion here, so our critical t times our standard error times all of this under the radical here, that's our margin of error. All right, so we're going to take our y hat plus the margin of error and minus the margin of error to give us our confidence limits. I almost forgot standard error is in there too. What's nice about this is we don't have to calculate standard error, which is just our sum of squares error over n minus 2, or the square root of that, but it's given to us right here. So when you do that regression analysis, it gives you the standard error right here. So that's nice. At least one little step saved. Okay. So some people like to try to break this down because this formula is so complex. Like they'll just do the part inside the radical and they'll call it radical or something like that, and then multiply it by the standard error and the critical t. Other people like to just do like something called margin of error, which is just all of these things. You can do it however you want. I'm going to set it up like this. So my margin of error is equal to my critical T times my standard error times, and then this gets really confusing because there's a lot of, so this is the square root of 1 over n plus x minus x bar squared. So that's that whole numerator. I actually probably should have put another parentheses around that. And then that's the numerator divided by our denominator, which is the sum of x squared minus the sum of x squared over n. So I'm actually going to put another set of parentheses around that as well. And that should do it. You can see that's pretty complicated, right? There's a lot of moving parts. And again, that's why people like to sometimes break it down into smaller parts. So that gives me a margin of error of 1.74. So now I can just do my upper confidence limit, which is y hat plus that margin of error, my lower confidence limit, which is y hat minus the margin of error. And that should be right. Let's check it. 3 decimal places, so 10.762 and 7.277. We got it. So after all of that crazy math, maybe it's important to ask ourselves, what does this actually mean? It means that given this data we have, with these 8 paired sets of data, that we're 90% confident that a team that scores at least 23 points, okay, the team that scores an average of 23 points, I should say, is going to win somewhere between 7 and 10 games per season. This might be valuable, right? If you're a coach and you realize, hey, if we can score an average of 23 points a game, we are going to be among the top half of teams. So that kind of tells you where to focus some of your efforts on offense, and then try to take this concept and put it into a business context, and think about ways you could do that as you looked at maybe your customers who meet a certain criteria, have an average number of employees, or have an average annual income, and then compare that with, say, your sales to them. And pretty soon you could start to really narrow down an idea of which customers are worth spending time and effort to really court as customers, and which ones maybe, of course, you wouldn't turn away their business, but you wouldn't invest as much time and effort into gaining their business. Okay, so that is 14.4.28T. I hope that was helpful. And again, if this, as you're going through this, is just you need additional help, don't be afraid to reach out.